Hello, everyone. Welcome back to another day of cloud computing. So a couple of quick admin things. Assignment 10 is going to be due Sunday, November 24th, not on the 17th. Quiz 10 opens today, and that's going to be due this coming Sunday. Your next assignment, which is assignment 11, is going to be due Sunday, December 1st. So there'll be a little bit of like strangeness because our last assignment will be the exam 3 review, but we'll have to do that together in class. So that'll actually be due before assignment 11 is due. And then your mid-semester project updates are going to be in D2L so soon, I promise. I apologize for the delay on that, but you'll have my feedback on those as soon as humanly possible. All right, so let's get into lecture 21. This is MLOps day 2. So recall from Tuesday that MLOps is just the standardization and streamlining of machine learning lifecycle management. And there are some key challenges with MLOps, specifically because deploying software code into production is pretty different than deploying machine learning models into production. So machine learning models are going to have some key considerations. The data is likely always going to be changing in a real world production environment. Your model needs to be available in different ways than your code or your application code will be available. You also need to do some additional monitoring for your model's quality and accuracy and fairness. And then it also is going to require some specialized talent like data scientists. And your ML modeling is going to rely entirely on open source software. So, all applications have some component of open source these days. Machine learning, though, takes that to the next level in the sense that almost everything that we build in the ML world comes from open source software. So, in addition, there's going to be different considerations for each of the machine learning families, let's call them. So each AI or ML domain is going to have unique considerations and implications in production. So generative language models are going to have infrastructure requirements for RAG or retrieval augmented generation that some statistical models aren't going to have. And we're also going to, in this lecture, we're going to just cover the most generic approaches that we can. But just keep in mind that your MLOps like architecture, your infrastructure is going to have specific requirements according to the task and the data that you're using. Okay, so there are some key steps to implementing machine learning in production. We have our model development, obviously. So that's when we're building and testing our model. We have to prepare our model for production. We need to build some data pipelines. Then, of course, there's model training and deployment, and then inferencing. Inferencing is the stage at which we are going to make decisions about unseen data. We're going to take some kind of action. We're going to respond to a prompt. We're going to classify something. That's our inference stage. Then we need to be able to serve our outputs and then also serve, our system actions. So those outputs might be from like LLMs. Our system actions might be that actual decision itself. And then we have monitoring of our models. We have retraining. We need to be able to intelligently know how our model is operating and if it needs care and maintenance. So if you'll recall our machine learning lifecycle, where we have our research questions, data collection and pre-processing, experimentation and evaluation, our model deployment, and then model serving, and then monitoring maintenance. This lecture is going to cover those last bits. We're not going to talk about the research question because we're really just going to be discussing the actual typical implications of these stages of our ML lifecycle. So let's start with data collection and pre-processing. So there are so many ways to collect data, and there's so many ways to kind of ingest data into a centralized place. So data ingestion is distinct from data collection, and it's distinct from data preprocessing. Ingestion is going to be where you're actually pulling data in to maybe like a warehouse or some centralized location for your data to live. So here are some tools that you can use: Fivetran, Singer, Stitch, Airbyte. There's a whole host of these. Choosing the right one, honestly, in the real world, it comes down to what your data engineering team likes to use, what you like to use, and then also, is it open source? Does it cost a lot of money? What is the support like? Do you know people in these communities? Things like that. There obviously are some technical, qualities to all of these tools, but a lot of them have feature parity. So when you're making these decisions, a lot of it's just going to come down to what do you like to support? What can you afford? What does your team like to support? Those kinds of things. So for streaming data, we're going to have some other options. We're going to have things like Kafka. There's Amazon Kinesis. There's Google has a pub sub streaming data ingestion tooling pipeline. And then you can also use tools like Apache Spark. So you probably learn about these in your big data technologies class. I really encourage everyone to take that class if you haven't yet, or if you're not planning to, maybe consider that. Next, we have some data orchestration and transformation tools. So this is where we're going to, kind of collectively as an organization define, how data is going to get into some purpose-driven model, maybe a particular view in your SQL warehouse, that sort of thing. So for data orchestration and transformation, we've got Apache Airflow, we have dbt, Dataform, Microsoft SQL Server integration services, and you can also just use custom code, right? You can write your own script to get data from your production SQL database into your warehouse or into a particular model or view in that warehouse. And then as far as what your warehouse options are, you have as many choices there as you do ingestion tools. So a really popular one is Snowflake. We also have Google BigQuery, which you've probably heard of before. There's Amazon Redshift. You can even just use an S3 bucket. You could just use object storage as your data collection storage endpoint. You can also use Databricks. So Databricks is super interesting. You've probably heard about it before. They are behind a tool called MLflow, which we are going to be using a lot of in the next couple of weeks. Now, for your experimentation and evaluation stage, we need to make sure that we can persist our experimental results. We need to be able to show like these hyperparameters worked well in this context. This was trained on this data. This was built with this model architecture. And we also need to be able to collaborate with other engineers. And one way that we can persist particular results and persist the parameters of our model is through a model registry. So model registry is just like a container registry. It's a specialized repository for storing your trained models. And your model registry can be served in a couple of different ways. It could be the actual image that you build around your model that you then store in registry. But there's also specific registry stores. So for example, MLflow, like you talked about just in the last slide, has a model registry function that you can use to then persist your model. There's so much infrastructure that you can use for persisting your model, including PyTorch. There's so much infrastructure you can use for building and persisting your model. So PyTorch, TensorFlow, you can use Hugging Face as a source for your models, DeepSpeed, MLX, XGBoost, JERX. And then as far as deploying your model into production, there are a lot of considerations here as well. So when we're talking about deploying into production, what I mean is once your model has been trained and evaluated and you're ready to go ahead and ship that into production, how do we get that model actually into our production environment? So first, we're going to talk about this first stage. So using CI/CD pipelines for deploying our model. And we'll talk about building model artifacts just after that. So our CI/CD for MLOps is going to actually include building the model, right? So you're going to use CI/CD to go ahead and build your model artifacts. So that could be persisting the model itself into your model registry. You could send that to long-term storage. You can run some basic checks, some basic sanity checks on the model. Take a look at feature importances if it's a decision tree type model. You can generate explainability reports for your model. All of those things can be part of your CI/CD pipeline, which is really great because then anytime a new model is deployed, it's going to go through a series of checks and it's going to go ahead and persist your model artifacts in some storage location. Again, that could be an S3 bucket, a model registry. That could be an audit table that you set up in a production SQL database. Then you're going to deploy your model to your test environment. In your test environment, you're going to go ahead and evaluate or validate your model's performance, right? So you're going to send it some test data. You're going to do some additional checks on this model in your test environment. You can also then determine the computational performance. Sometimes at inference, you might have a worse performance than you might think because you haven't provisioned enough compute power behind it. Once it's done its test environment checks, then you can go ahead and deploy your model to production. And all of this can be done through CI/CD. You can define that through code and pipelines. So next, we want to persist our model artifacts. Let's go into a little bit more depth about what those model artifacts actually are. So first, we're going to have the code for your model and the code for your preprocessing. Now, the code for your preprocessing, like we've discussed, could actually be its own microservice if it needs to be reused at inference time. That's one approach. If it doesn't need to be reused at inference time, then your code for your model and preprocessing can all be munged into one service, and then you can process that as part of it. Then you want to make sure that you're recording your hyperparameters and your configuration for your model. That is going to help make sure that our models is going to be deterministic as best as we can. So we want to make sure that we've recorded, the max depth of our decision tree. We want to make sure that we've recorded the decision criteria for our decision tree, things like that. So that way people can go ahead and reproduce that. Any additional configuration you've done for your model, maybe the number of epochs or the input dimensions, things like that. Then we want to make sure that we have some way of persisting our training and our validation data. We've talked a little bit about using hashing to persist our, to make a record attestation for the data that we have trained on. So we can use a couple of different tools for hashing our data set, including in Toto, and or we can actually just go ahead and persist queries that we used. We can persist the CSVs if we trained in CSVs, those kinds of things. That way, it's going to really help us understand, our model's results at training time. And then we, of course, need our trained model in runnable form. So that is going to be a specific file object type. Excuse me. That would be a specific file object type, either a PITL file or a joblib file, something that another program can read. And so when we are saving our programs to disk, I think I will go over that in our code walkthrough from 2 weeks ago. When we persist our model to disk, what we're going to do is persist that to some kind of file that can then be read by another program. We also want to make sure that we are persisting our environment, including new libraries with specific versions, environment variables, things like that. That's generally going to be done through the container image that you build that can be used to serve your model. Then, of course, we want documentation. Documentation in this case might actually exceed documentation requirements for any other service because you want to make sure that you're documenting the rationale behind choosing this model. You're documenting the rationale behind the hyperparameters that you chose, all of these things. So that's a really important piece, especially when it comes to reproducibility and especially when it comes to justifying a model's decision. And then we want to persist any code that we used or any data that we used for testing. So these can all be thought of as ML model artifacts. And they're really important to keep track of. When we're doing this in production in real life, it is very different than running a quick decision tree locally on your laptop. There's a lot of requirements because this could be scaled up to many millions of users. If you're making millions of decisions a day about people or about your end users of your platform, you need to make sure that you have absolutely everything you need to explain that decision, to justify that decision, to inspect that decision, to make sure you don't have bias in your model. And by persisting your model artifacts, you're going to be able to understand earlier decisions that your model made, maybe months ago, maybe years ago. Okay, so let's talk about some deployment strategies for our model. Um, it's going to depend on what makes sense for your environment and what makes sense for your model. So if you're deploying an LLM that's going to be hit in many, many millions of times a day, then you're going to want to think about using something like Kubeflow to serve your model, right? That's going to be able to serve your inferencing endpoint through Kubernetes, and you can use auto scaling. You can have all of the benefits of container orchestration in that way. If your model is going to be doing some batch processing and really the key resource in that batch processing is going to be memory, very memory intensive process, then maybe you don't really need a distributed environment. Maybe you just need a really, really beefy VM that you're going to just stick your inference service on. So some deployment strategies that we want to keep in mind are things like avoiding downtime, especially with real-time scoring. So when we want to avoid downtime, we need to think about high availability. We need to think about all those strategies that we've talked about throughout the semester. Making sure that our uptime is within our SLAs. So if you have a 99.99% uptime agreement, then you need to make sure that your inference endpoint can support that. We also have another type of thing to think about, which is like how we actually move like the new version of a model into production. So if we're using scalable infrastructure for our inference service, and we want to deploy an updated version of our model, then we can use something called a canary release. So a canary release is going to be when a stable version of your model is kept in production, but then a certain percentage of your workload of your nodes are going to be redirected to the new model. And then you're going to monitor those results. So it's often used in like A/B testing approaches, right? So some percentage of your environment is on the new and some percentage is on the stable. And then that way you can really understand like how your work is performing in real life scenarios. That also means that you can roll things back really easily, which is very, very important to do. So as far as deploying your model, there's a few options for production. You can have one model deployed on one server. For your group project, this is all I'm expecting. If you wanted to deploy your model on DOKS, you are welcome to, but if you have one model deployed on one server, I'm happy. You can have one model deployed on multiple servers for high availability. You can have multiple versions of a model deployed on one server. I don't recommend it, but that's something you can do. And then you can have multiple versions of a model deployed on multiple servers. Again, that's some additional complexity. And then you can have multiple versions of multiple models deployed on multiple servers. So, there's a lot of different ways that you can go about this. In this case, your servers are going to be your nodes. You can have a bunch of different kinds of models all running in production at the same time. In order to do that, you want to think really, really carefully about your namespaces. You want to think carefully about the version tags that you're using for your images. All of these things are going to really come together in order to make sure that you can have many machine learning models running in production at the same time. Okay, so moving on to inference. There are kind of two larger groups of inference. We talked about this a little bit last time. We can do batch scoring, or we can do real-time scoring or online. With batch scoring, whole data sets are processed using a model. So that will be like a daily scheduled job. And with real-time or online scoring, then small numbers of records are going to be scored. So for example, when an ad is displayed on a website and a user session is scored by models to decide what to display, that would be real-time scoring. Or a user signs up for your platform and you want to determine if their browser is real or if they're using spoofed headers, that would be real-time scoring. Then we have our monitoring and maintenance. And this is a really critical part to how successful your ML project is going to be. So we need to make sure that we can understand what's happening in our model and in our system as well. So it's not just traces. We need to add in some additional observability here to make sure that we can understand model drift. So that's another new piece in MLOps that we need to think about when it comes to observability, monitoring, and maintenance. In addition, we want to do some resource monitoring, right? So how much CPU is our model using? How much memory? How much disk? How much network? We want to make sure that we can do heartbeats. So we can do health checks on our nodes anywhere that our model is being served. Then we also want to make sure that we're recording our metrics. So accuracy, precision, recall if one, if it's supervised. If it's unsupervised, you might want to persist the silhouette scores of your clustering algorithm, for example. And then that's going to help you detect when your model is going stale. That is going to be a clue for you to know, okay, it's time to retrain our model or maybe update our features. Maybe we have a feature that we need to scale in a different way, those kinds of things. Now we have our model metadata. So what version of our model are we using? What were the model's inputs at decision time? What were the model's outputs at decision time? What was the system action that was taken? So for example, what was the decision itself? Was it to block or to allow, whatever it is? And then what was we need to make sure that we store our model evaluation metrics. So some of the tools that we can use once we've stored all those things to better understand our model in like real time is data viz tooling, which if you've taken that data visualization class, you'll be really familiar with these. There's so much, and also from our observability lecture. So there's a lot of data viz and alerting and observability tools out there for us that we can use to monitor our model in terms of performance and also in terms of resource utilization. So we have things like Looker, we have Tableau, we have Power BI, and there's Prometheus and Grafana, and then you can even define your own dashboards in code. There's a lot of ways to do that in Python, in JavaScript, and that's becoming a popular approach as well. Okay, so putting this all together, we have our data ingestion tooling. We might have Kafka, Kinesis, dbt, Airflow. Then we'll have our data preprocessing service. We'll probably use Pandas and NumPy. Feature engineering and selection, we have scikit-learn for that. Our model building and training, we have TensorFlow, PyTorch, those good tools. For our model evaluation, you can use scikit-learn and MLflow. For our model deployment, we have TensorFlow Serving, TFX, Kubeflow, Google ML Kit. We have SageMaker. We'll talk about SageMaker in a little bit. And then for monitoring and maintenance, we have Prometheus, Grafana, Tableau, Looker. So all the tools that you use are going to be dependent on the environment and dependent on the model that you're trying to build and deploy. So here's a cloud agnostic machine learning lifecycle diagram that also shows, the overall architecture of how our machine learning lifecycle is going to work. So we have all the way on the left, our data collection and our data preprocessing and our feature engineering, right? So these are all going to be maybe like standalone scripts that we write. Once we have our preprocessed data, we probably want to store that in some offline feature store. We'll discuss that just for a second. We might even have an online feature store. We're going to keep moving to the right in this graph. So we can then do training, tuning, and evaluation of our data, of our model rather. For that, we're going to pull things from our feature stores. We're going to pull data from our feature stores. From there, we're going to deploy our model, and then we can do batch inferencing or real-time inferencing. And then once we do our inferencing, that's going to get sent to our application. That decision will get sent to some UI somewhere or some other service that's calling our model. We also want to make sure that we're monitoring our deployment. We have some alarm managers set up. And then we also have some loops. We've got a feedback loop, a performance feedback loop, and we have model drift feedback loop and our active learning feedback loop. So, and then in the very bottom, we have our model registry. That's where we're going to store our artifacts, our data, our code, our model. All right, so let's talk about this offline feature store. This is going to reduce duplication, and it's going to reduce the need to rerun feature engineering across teams and projects. So if you can do feature engineering just once, go ahead and do that. An online store with low latency retrieval capabilities is going to be ideal if you have a real-time inference requirement. But if you are just doing batch inferencing, then an offline store is going to be just fine. It's designed to maintain a history of your feature values, and that's going to be suited for training and batch scoring. Your model registry, like we discussed, is a repository for storing your machine learning model artifacts. That's going to be your trained model and any related metadata. So the data that you used, if it's the full data or the hashed data, the code, the model version, all of those things. And it's going to enable the tracking of the lineage of your machine learning models. And then it could also act as a version control system, which is great. Then we have this performance feedback loop. So the performance feedback loop is going to inform this iterative data preparation phase. And that's going to be based on the evaluation of the model during the model development phase, right? So, as we understand how our model is working or if it's working well, as we tune things, we can have this performance feedback loop that's going to inform our data preparation. We have a model drift feedback loop. This is really key part of this and something kind of novel for MLOps, which is the model drift feedback loop is going to inform this iterative data preparation phase based on the evaluation of the model during the production deployment phase, right? So as we've deployed it and we're continuously evaluating it and monitoring it, then we can actually use that to inform our iterative data preparation phase. We can say, okay, this feature's working well, this feature's not working well. What do we need to do next? And then our alarm manager. This is going to receive alerts from our model monitoring system. It's going to publish notifications to any services that can deliver alerts to the target applications. So that target application might just be an email server where it's going to ping Professor Zara at 2 in the morning that her model is not doing what it's supposed to. The model update retraining pipeline is one type of that target application. Lastly, we have this scheduler that's going to initiate a model retraining at business-defined intervals. So if you have if you want to retrain a model every week, and that's great. You can set that up with a scheduler. If you want to retrain the model every time evaluation or performance dips below a certain metric, you can also set that up with the scheduler. And then our lineage checker. This is just a way of enabling reproducible machine learning, which is critically important in academia, in industry, in research, everywhere. It's going to enable the recreation of your machine learning environment at a specific point in time. So you can understand the data that was used to train that model, the model version, all of these things, all the decisions that it made. And that's going to help reflect all the resources and all the environments at that time. Because sometimes you're going to be in court and you're going to have to defend your model's decision. And you're going to have to say, okay, this is exactly why this model made this decision at this point in time. So your lineage checker is going to be able to help you with that. So let's talk a little bit more about your lineage checker. So this can be based off of a few different components. Your lineage checker can be deployed using infrastructure's code. So you're going to commit infrastructure's code changes to your version controlled repository. It's going to have data. So that will either commit change or archive a database snapshot, for example. Your implementation code, you're going to commit any changes to your implementation code to version control repository. You have your model feature list. So that's any features. You could do an archive feature snapshot on that. And then you'll have your model algorithm code. So you're going to commit changes to the version control repository. Then your model container image, you're going to commit any changes to your container repository. So infrastructure as code piece, this is going to be modeling, provisioning, and managing your cloud resources. And that can all be done using IAC. So you're going to be able to take advantage of IAC to eliminate configuration drift between your testing and production environments. Then for data, you're going to store your data schemes and your metadata in version control systems, just like we would our code. So the location or a link to the data can be stored in a configuration file, and then you can store that in your code version control. Yeah, also. Then we have implementation code. So any changes to any implementation at any point in time can also be stored in your version control. We have our model feature list. So that's going to be like a feature store, for example. So that's going to maintain the details of the features as well as the previous versions for any point in time. And then we have our model algorithm code. So changes to any model algorithm at any point can be stored in your version control. Yeah. And then your container image, of course, right? So versions of your model container images for any point in time changes can be stored in your container repositories. and that can be managed by your container registry. Okay, so let's talk through some architectures. So at Google Cloud, if you were to do ML with Google Cloud, you have all of your data sources on the left. So that can be BigQuery, that can be Cloud SQL, Vertex AI Feature Store, or Cloud Spanner. When you do your data extraction and validation, you can use, that could be through raw data, or that could be through TensorFlow data validation. And then we'll have our transformations. So TensorFlow transform, and then you can save those transforms to cloud storage. That data is then going to be fed to your model training and tuning. You can use Vertex AI training, and then you're going to save your stored model. Then that's going to go to your model evaluation and validation, where you're going to evaluate it using TensorFlow model analysis, and then save, again, those evaluation metrics. Your saved model can then also go to model storage through Vertex AI model registry, and then you can serve it with TensorFlow serving on Vertex AI registry. So with AWS, we have SageMaker, and SageMaker is supposed to be like an end-to-end ML lifecycle management tool that also is going to help you persist your model versions and keep track of all of your model's metadata. So maybe in your user account, you have Amazon Elastic File System, and then you have a VPC with one private subnet. That private subnet is going to talk to Amazon S3, maybe for your training data. It'll have Amazon CloudWatch logs. It'll talk to the Amazon SageMaker API itself, the Amazon SageMaker runtime, and the Amazon SageMaker feature store runtime. And then as a user, right, you're going to interact with the SageMaker service account so that you can use your SageMaker platform VPC. There'll be some authentication proxy there to another private subnet where you'll have your Amazon SageMaker Studio domain. So you'll have a SageMaker Studio domain that'll be your corporate domain.sagemaker.aws.something. And then you're going to be able to interact there and be able to set up your ML pipelines. So your full process with SageMaker might look something like this. You might have your on-prem code repo. Once you push that, you can push that to a shared service account with CodeStar and Code Pipeline, Code Commit, things like that. You then can send your results to your model registry or your container registry. And then you'll have a code pipeline that will get sent to an approver. On the bottom, you can have a test account that uses CloudFormation, which is IAC, to set up your SageMaker processing and training and any Lambda functions you might use. And then you can also have a prod account where you'll have your CloudFormation set up your SageMaker endpoint and an API gateway so that can be interacted with by any other application that needs to use it. So kind of overall, your AWS CloudFormation template, will drive like your product portfolio. You'll deploy that IAC to AWS Service Catalog. And then you can define your SageMaker project with all of its resources. And then you deploy that through to Amazon SageMaker. So that can use any kind of compute resource that it might need. That could use Lambda functions. That could use EC2 instances. And then you have your data stored in an Amazon S3 bucket. In this case, maybe there's a Lambda function to start the pipeline as soon as a new file ends up in the Amazon S3 bucket. That will go ahead and start SageMaker. Then your feature store group will ingest any data from that pipeline. And then you'll have your AWS code commit, code build, and code pipeline as your CI/CD. So I want to really encourage everyone to go ahead and take a look at this URL. This is ai-infrastructure.org. And this is a really, really great place of seeing all of the tooling that's out there to help you with your end-to-end machine learning lifecycle. There is so much stuff out there. It's really not practical to even cover a third of it. So it's a really great place to understand what different projects do, how they map to our machine learning lifecycle, how they map to the different stages, what functionality is there, all of these things. So if you just need a quick overview or reference, take a look at the AIinfrastructure.org website. I think you will really enjoy this overview, even if it is a little bit overwhelming. This was in your reading, so I encourage you to take a look at the AWS well-architected framework, and then as a refresher, and then go into the well-architected framework for machine learning systems. This is a really great way of kind of checking yourself to make sure that each stage in your machine learning lifecycle is, has high availability, that it's secure, that it's reliable, that it's performant, and that you've optimized for cost as well. Thank you so much. So this is our lecture for today. Your quiz will be available online pretty soon. And if you have any questions, feel free to ping me in Slack. I'm back from KubeCon on Saturday, and we'll be happy to answer any questions in the meantime. Thank you, everyone.